All right, sorry guys. I know that that was frustrating. My first class went perfectly without any issues on Zoom, and then for whatever reason, my computer apparently just couldn't handle everything and decided to spin. So it is frustrating to say the least on so many levels to just not be in the classroom, um, but also to then try to go at least in real time and then have that happen. So I couldn't imagine truly being a big time corporate exec using Zoom and then for whatever reason not being able to use it. So what we were talking about before, who knows, before the ball started spinning on my computer and nothing could be done, is we were talking about our proofs on the ENC pages and looking at how we're going further than just saying that it's side, 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 or just saying that it's angle, angle. In this situation, what we're looking at is at least our proof statement does give us an idea that we are talking about similar, not just that we're in this chapter. But right here in our proof statement, the fact that we're looking for something that deals with proportions tells me that we are dealing with triangles that are similar. So at least that's the big hint that this isn't going to be something where we were wondering, is it congruent? Is it not congruent? We at least know that that's our hint for how this works. When we do go into our proof, just like always, we know we're going to have our given statement, but put in just so that you can now match the corresponding pieces better, especially if things were spun around. We want to be able to make sure that we do have that. And then we are going to also write these other two given statements. I know that they're in line 1, but they're not crammed in there, so we're still able to see all 3 of them. But notice I'm not putting in the tick marks yet. So I don't want to put those tick marks in yet because what I don't want is to forget that I actually have to say that because of perpendicular, I need to state that angle B and angle E are right angles. And that's our definition of perpendicular. And because they're right angles, I can now say they're congruent because all right angles are congruent. And now I can put my tick marks in so that I make sure that I don't do it too soon and forget these 2 very important lines. That's stuff that was still happening, so I wanted to make sure that we address that. Now, finally, what we're able to do is because we can see that we're talking about similar triangles, I do already have 2 angles, so I am able to name the first triangle, and notice how everything on top has to do with, or at least I should say listed here. I'm going to keep it kind of in an order, so I'm going to say A, B, C is similar to triangle D, E, F, and my reason is angle, angle, similarity. Then what we're going to do is we're going to take a look to see, does the pattern match? Is side AB and BC, now I understand they're in the same triangle. Layla! Sorry, she has not stopped whining since, of course, I've gone live, so it's clearly going to be a fun day for me. AB is this side, and it doesn't have a tick mark, and it has a right angle, and then we're going to go BC, which is the right angle and the bar, or the single tick mark. What I'm looking at is for the pattern to match, I go DE, which matched, and then EF has the same pattern. So because we can tell that whatever our ratio is from one will match the ratio for the other, regardless if I know, because I'm telling us the triangles are similar. My last line will be our prove statement. Patterns match. The triangles are similar, so they should be in proportion. And I would write, if triangles are similar, then sides are proportional. And there is no CPCTC shortcut for this. I have to do my if-then statement. It has to be the if-then statement. Now I could have had, and I'll make up one here in a second, the same idea, but we would have had, if we would have said prove angles congruent, you would have had the same idea. If triangles are similar, then corresponding angles are congruent. So this idea is just like our CPCTC, but we have to write it out as an if-then statement. So I'm going to go back to see where my E and C pages were. And I'm going to check again on that page. I'm going to pull up another proof. Layla. And I'm going to look at this next one, and then we'll be done for the day, just so that you can see that there's the look of it is different, but the idea is still the same. Now I know I've told you on a number of occasions that I offered that extra credit problem, thought it was 17 lines, and was going to give everybody all this extra credit, and the young lady Cassandra came up and had it done in 3 steps. So the minute I started saying let's do this problem, that's where my brain went up. We're going to prove triangles similar. We're going to go ahead and work with this CPCTC idea. But there might be a way out here to make this a little bit shorter. So let's just talk about what this guy looks like. All right, so what I want to be careful with is the fact that we do have that these are parallel. And that does bring in this proportionality idea where the top and bottom, we just started on the Zoom lesson, we talked about that converse, that if these were in proportion, that our sides would then be parallel. So it is the converse of our proportionality theorem that we discussed at the beginning of the Zoom lesson. So initially I was like, oh, maybe that's what we could do here because I see this as parallel. But I'm looking at what they're having us match up, WS and XY, and then so we may need to worry about what happens if we separated these triangles. So let's go ahead and again, we're going to start with our given statement. And in number 1, we are going to talk about WZ is parallel to XY, and that is given. And I'm going to go ahead and I'm going to put these tick marks in here. Now, the minute I see XY is involved, I cannot use the proportionality theorem. I cannot use the shortcut. we have to talk about the full triangles. So let's talk about what these parallel lines will allow us to see in this picture. It will allow us to talk about our corresponding angles. Those parallel lines will allow us to talk about these corresponding angles. So if I pulled these two triangles apart and I drew the smaller one, SWZ, with its tick marks, and the larger one, SXY, with those tick marks, what I now know is those two triangles separate are going to be similar by angle, angle. So to save myself, and I get it, angle S is reflexive. I could have absolutely talked about angle S and used that as one of my two congruent angles. I'm going to actually talk about angle SWZ is congruent to angle X, and angle SZW is congruent to angle Y. And if lines parallel, corresponding angles are congruent. And that way I only have to write my reason once. I know I kind of crammed that in there, but at least I only have to write my reason once. Now I know that these two are similar, and these two triangles are similar by angle, angle. So SWZ is similar to triangle SXY, again using the same pattern, by angle, angle. Now, here's the trick. I need to look at this and realize that cross multiplication has happened. So I need to make sure that I'm paying attention that cross multiplication has happened. We have done our means extremes product theorem. So keep in mind that this had to have come from a proportion. So that's what I want to look at. I want to figure out, how do I put this back into a proportion? So in line 4, what I'm going to do is I'm going to state the proportion according to, if I have WS first, it had to have cross multiplied with XY. So notice how I did that. I made sure, and I'll zoom in so that you can kind of see that happening. It told me WS was multiplied by XY. The only way that can happen is if they were opposite each other in a proportion. The only way that could happen is if they were opposite of each other in the proportion. I'm then going to look at where S is and WZ. Notice that WS is this side, SX is this side. So I could set it up where they were corresponding, and I can put them right above and below each other in our fraction, because they do correspond. And if I look here, WS and SX are first and the first two. So there's quite a few ways to know, where should I put the SX and the WZ? Kind of makes sense. Here's the first two, here's the first two. So let's go ahead and group them in that same fraction, because it's telling us everywhere they correspond here, they correspond here. I know as long as they're above and below each other, they're not going to cross multiply, but I do know that I'm supposed to multiply this with WZ. Now, the reason I spent so much time talking about that is, again, I know you're going to wonder if I would have just written down that ratio or that proportion, where did it come from? I'm using my picture. I'm using the fact that I know that if triangles are similar, their sides have to be in proportion. I'm going to say that again very carefully. If I know triangles are similar, two requirements are always going to be fulfilled. All corresponding angles are congruent, and all corresponding sides are in proportion. So here's my corresponding sides. They are in proportion. I used this to help me know where to put them. I used the picture and the similarity statement to help me know where to put them. Now my reason is just like we said in the last one. If triangles are similar, then corresponding sides are proportional. And obviously we know that the last step is now going to be to show that that multiplication has happened. So we do have WS multiplied by XY will equal SX times WZ. And we don't say cross multiply. We do, however, call it the means extremes product theorem. So you are going to see that I'm going to, here before the end of the day, load for you some E&C problems that have been worked out so that you can practice them on your own, and then you won't have to worry about how do I do it if I can't ask the questions readily. This would also be a good opportunity for you to make sure that if you find any of them in what I've assigned for you to practice, again, they're not required yet. If you find any that you need practice on, you'll take a screenshot of them, you will email me, and we will address them at our next meeting. Whether it's a live stream, whether it's Zoom, just make sure that you always check the video to make sure that you know what we went over. So I will then talk to you guys the next time. Have a great afternoon.